Hi, it's David Teedy again with a continuation of some discussion of the equation editor. I forgot to discuss one of the equations in my last video, so I'll include it now. This was the equation. Basically, you could handle the ratio, and what's new about this is the V bar, which stands for the average of something. How would you enter that? It turns out there are a lot of characters available within Word that have the accent marks, and you could enter them that way. But the equation editor can do it in a general fashion. That symbol is called a macron, and it turns out that there's a whole tab here for accent marks. Let's see if we can find one that looks something like that. Here we go. There's a bar over it. And so we can enter our V, and we've just created the V bar. I won't create the rest of the equation, that's sort of self-evident. But there are some other things I'd like to talk about in the insert equation. Let's take a look at it a little bit. Over here we have a bunch of symbols: plus, minus, infinity, equals, not equal, approximately equal, multiply. Sometimes, let's say you have a quantity in parentheses times another quantity in parentheses, and you want to indicate multiplying them. Between those two, you would use this x, for example. Before, we had rather simple things, like a times t, we just type it as at. Here we have the division symbol. You could use that if you want sometimes, instead of maybe one of these fraction options. This stands for factorial. If you have n factorial, it means n times n minus 1 times n minus 2 times 1, and so on. Proportional symbol: less than, much less than, greater than, much greater than, less than or equal to, greater than or equal to. This is sort of the opposite of the plus or minus. This plus or minus is something you would use if you're constructing that solution for the quadratic equation. Approximately equal, almost equal, identically equal, bunch of for all, some logic symbols. Let's go through them all, I guess, here. This is a complement of something. This is used for constructing partial derivatives and things. We won't be doing that. Sort of a general radical sign, although you've got a whole tab over here for special radicals. If you do this, then you can insert whatever you want inside the radical. You could use this when constructing your solution to the quadratic equation. If you want other more general roots, you could put whatever number you want in here, cube roots, fifth roots, seventh roots, whatever. Usual special cases, square, cube, cubic root. When you were doing your quadratic equation solution, since that's such a common radical, you can click on this and you got the whole thing in one fell swoop. And then once you knew the values for b, you can actually, edit those and put in whatever those values were. That was, for example, going to be a v0. That could be v sub 0. So I've sort of done half your work there. And you can select something and override it. Also, another little trick: if you've created equation somewhere and you need the same thing over again, you can go into the equation editor and select it, do a Control C to copy it. Let's actually do that just to illustrate, and then go down for and a paste. Control V to paste. So it'll save a lot of typing sometimes if you've already created pieces you need again later. Let's go back and look at some more of the equation editor parts. This is some set theory symbols. We won't need that. Percentage, the degree symbol. It's might be useful, like degrees C. But they actually have special cases, so you don't have to even go through that much. For example, here's degrees Fahrenheit, degrees C. This is a delta, it sort of stands for increment or difference. This sort of logic symbols, you won't be doing any of that. Pointing arrows, you probably won't need those. If you're doing some proofs, therefore, just simple plus and minus, a not sign. I've never ever had to use that. And then we have the Greek alphabet, lowercase alpha through omega. And asterisk sometimes might be used for multiplication, but I prefer probably the big X for multiplying. I'm not sure we'd need anything else. If you're doing proofs, this would be the end of the proof. You might have a therefore, and then the QED, that which was to be proven, the end of proof. Some other things. This is for integrals. We don't have any integral calculus. This is for summations. I don't think we do any of that particularly. We already talked about brackets. We haven't talked about this yet. There will be some trig functions. So if you need the sine of something, or any of the trig functions, or the inverse functions, or the hyperbolic functions, you can construct them. Some of the common ones, like sine theta, or tan theta, which is ratio of sine over cosine, you can just do in one click. If you wanted the sine of omega, you would do it by function sine, then go get the omega out of the alphabet, and you've got it. Oh, what did I do wrong here? Let's back up. Omega. Try it again. There, okay. So, take one more quick look. I don't think I mentioned to you that besides the angles, or not the angles, but the degrees, yeah, I have special ones for degrees Fahrenheit and degrees C, so you don't have to enter them as a construction. Some other comments related to your mastering physics homework relate to that Greek alphabet. Let's take a look at that. One of the symbols is rho, and you'll stuck it in here. But that rho will appear in your physics homework, and you'll have to enter it using the Mastering Physics equation editor. But it looks a lot like P, and so if you enter it as P, it'll not know that that's right, and it won't tell you, and you'll keep fussing with the equation and can't figure out why you can't get it right. So be careful when they're talking about rho, when you're using their equation editor, that you use the correct Greek symbols for what they're looking for in the way of the answer. Some other things that might be useful. When you're working on the Mastering Physics homework, if any of the problems are numbered something like 2.25, that problem was taken directly from the problems in the textbook, and all problems which are odd numbered have answers in the back of the textbook, and sometimes those show up in your Mastering Physics assignments. They won't have the same input conditions, but you can work the same problem in the textbook and check your answer until you can get the answer that's in the provided answers. And then once you know how to do the problem, then you can do the problem in your assignment, and you'll have be pretty assured you can get it right without wasting all of your tries. Another thing to check out is I've provided some helpful hints on Blackboard under the tab for resources, and then under that there's a comments about mastering physics. So I don't actually give the solutions, but I give some hints or ways to think about the problem. Uh, maybe even given some steps if there's like 2 or 3 steps involved to get to the answer. And if you read those hints and follow those suggestions, you'll have a much better chance of understanding how to go about solving the problem. So I hope these hints are helpful to you, and wish you all great success.